welcome to the Office of Undergraduate Research Education series. Today's session is on finding your journey with energy, and our speaker is Dr. Luisa Whittaker-Brooks. And this is a virtual event and it's being recorded. So we ask everyone to mute themselves and to turn off your camera to ensure the best experience. But if you have questions, please use the chat feature or you can unmute when you're invited by the speaker. And this is the event evaluation. We would love everyone to complete this after the presentation, but we wanted to remind everyone that specifically the SPUR, Europe, and early exploration scholars that they need to fill this out in order to get credit for attending. And the mission of the Office of Undergraduate Research is to facilitate and promote undergraduate student faculty collaborative research and creative works in all disciplines throughout the U campus. And we would like to acknowledge that this land, which is named for the Ute tribe, is the traditional and ancestral homeland of the Shoshone, Paiute, Goshute, and Ute tribes. The University of Utah recognizes and respects the enduring relationship that exists between many indigenous peoples and their traditional homelands. We respect the sovereign relationship between tribes, states, and the federal government, and we affirm the U's commitment to a partnership with Native nations and urban Indian communities through research, education, and community outreach activities. And now I'd like to introduce our speaker today is Dr. Luisa Whittaker-Brooks. She's a professor in chemistry.
Hey, thank you for the introduction. So today I would like to take this hour to just take you through my journey in chemistry. And I'm a chemist, and we actually do a lot of energy-related research. But I would like to give you an outline of what I'm going to be discussing here. So I will tell you a little bit about my background, then what inspired me to be to pursue a PhD in chemistry, and the journey to success after I became a faculty here at the University of Utah. Okay, so I'm originally from Panama. Panama, the country, not Panama City, Florida, where they probably have like 20,000 hurricanes right now, right? The nice thing about Panama is that we are not in the path of hurricanes. So we don't get a lot of hurricanes. We get the aftermath, the floodings and all that stuff, but we are normally not directly hit by hurricanes. They typically go to Nicaragua. Okay, so the thing about Panama is that it's normally known for the Panama Canal. So we have a small strip of land here that ships can go from the Pacific Ocean to the Atlantic Ocean and vice versa, right? And this was actually because of the French. They thought about building a canal through the country, but they brought in a lot of Asian laborers. But something that they underestimated was the heat and the amount of diseases that we have in that area. And a lot of the Asians workers that started building the Panama Canal, they actually died of yellow fever because there was not a vaccine for that or treatment at that time, right? So there was a guy that came in and developed the vaccine, and then the Asian workers were actually replaced by Black workers. So the ethnicity of Panama is pretty diverse. So we probably, in terms of population, we have about 15% Asian. So there's a lot of Asian and people in Panama, 15% African, whites, and everybody is just mixed. And I would like to actually point out here that we actually have about 7 different indigenous groups that are actually protected by the government. So I cannot even go to their land, right? And the thing is that this beacon of ethnicity makes our language very rich, right? So in our Spanish, we actually use a lot of Asian slangs and African slangs. So a lot of Asian peoples, particularly Chinese, sometimes they're impressed that I can understand what they're saying, right? Because I recognize some of those words. Okay, so even though that I'm professionally a nerd, I do not identify myself as a nerd in my daily life, right? Something that is a passion for me is soccer, right? And I play a lot of video games, not so much as I used to do as a student, but I still do, right? And I remember back a few years ago, exactly about 7 years ago, Panama was in the World Cup. And I mean, there was no probability of us winning the World Cup. And it was our first time at the World Cup. So I played in my PS4 and I made Panama win the World Cup. So for me, they're actually the World Cup winners. Okay, so one of my favorite teams is the women's soccer team, and I support them way more than I will support the men team because they have a lot of different drama going on, and I think the women team are actually stronger. So the women team had a friendly game against Colombia a few months ago that I actually took all my research group to watch the game. Okay, so just to give you a little bit of overview of my education. So I grew up in a city called Colón in Panama, and it's in the coast, the Atlantic coast. So it has the best beaches that you will see in the entire country. The downside of that is that we also have the highest crime that you will find in the entire country, right? So so I grew up seeing people being shot in front of me. I grew up seeing people like women being raped in front of me, right? So people that had a lot of drug addiction going on, a lot of cartels and things of that nature, right? And growing up in that environment, normally they don't bet on you, right? So you don't have a lot of different opportunities going on. So I got a scholarship to study at one of the most prestigious high schools in Panama. So it's a very conservative Catholic school. And then from there, I went to the University of Panama to get my bachelor's in chemistry. When I finished my bachelor's, things got a little bit sketchy, just because Latinos normally are known for partying a lot, and I do party a lot, right? And I remember going to this club, and I met two Americans. And those two Americans asked me, what do you do? Like, do you go to college? And I'm like, yes, I go to college. They're like, what are you studying? I'm like, chemistry. They're like, oh, you're smart, which you always get that comment. And they're like, oh, we have the perfect job for you. And I'm like, well, I do not do drugs. I do not know how to manufacture drugs or any of that kind of thing. That's not the type of chemistry I do, right? But they're like, no, I want you to help us with statistics. I'm like, oh, I can do that. I'm really good at math, right? The problem is that this was bidden, right? So basically what I had to do was run statistic analysis on lines that were coming from Las Vegas, and I became a sport bookie, okay? Not so much not today, but in that time that was illegal, right? And I actually had they were rated, so they were rated in Costa Rica, and then they ended up in Panama, and then as part of that raid, I was involved in that, right? So I actually had to think about ways of getting out of that and not going to prison, right? So then I thought about, well, probably I can go back to chemistry, as much as I love the statistic portion of sports. I'm not going to lie to you. Right? And I still do, because I actually look at these betting lines very closely and figure out ways of where they're messing up the lines in Las Vegas, so I can identify that. And then I'm like, well, can I actually think about doing a PhD in chemistry? So I remember writing this letter or this email, and the way that I found this letter, and I'm just going to talk as you are reading this, the way that I found this letter is because I was going through my Hotmail account, and this letter I found it, or this email found it when I was actually a professor already here at the University of Utah. And I came across this email because I was shutting down my Hotmail account, like who uses Hotmail, right? So I was like, all right, let me see what I have in this account that I need to rescue or download or send to another email or something like that before I close it down. And I came across this email. And then just looking in retrospect, and I see this email and I'm like, how, by looking at this email, how am I here, right? Probably when I drafted this email, there was no Google Translator, but I'm pretty sure that Google Translator could probably do a better job than that, right? And I just broke down in tears, just reflecting in the journey and where that journey actually started, right? Okay, so I then drafted that email, and then I applied for Fulbright. So Fulbright is a international scholarship that gives you the opportunity to study abroad, right? And Panama being a small country of 4 million people, small, 4 million people, it only grants 6 of these scholarships per year. I think they have increased a little bit, but in that time it was only 6, right? And I just want to bring you to my CV or resume or whatever you want to. There's so many no-nos in here, right? So one is my very sexy picture here. That is my high school graduation picture. I'm glad that I'll actually look the same, right? Just with a little bit of gray hair, but we can fix that. Okay. It has all my personal data here, right? So addresses, all my home address, phone numbers, email, even my blood type, my Panamanian social security number, right? So I put all this information that is a no-no in a CV, right? And then I put this objective application here, which has a lot of typos, and it was just a disaster, right? So I was very lucky that with a resume like this, I actually made it to be a finalist for the Fulbright and eventually get a Fulbright scholarship, right? Okay, so with the Fulbright scholarship, I ended up at the University of Buffalo. So Buffalo, New York is known for the Niagara Falls, right? And the struggle was real. and why do I say that? Because I was coming here by myself. There was a language barrier, a cultural barrier. I remember in the Latino community, we kiss everybody regardless if we know them or not. And then here is just like very dry handshake. And I was like, oh my God, why these people are just so cold? Like, it seems like nobody want to talk to you, right? And there was a lack of support, very dry relationship that I really struggled to get used to, okay? And then the lack of people that look like me in a PhD program, or the lack of mentors in a PhD program, right? But I was not the only one feeling that way, right? So I found a network so that is actually something that I'll encourage you to do. Find a network when you are struggling to, that sense of belonging, like, do I really belong here? And sometimes I go through that, even as a professor right now, right? So I found my network, and we realized that within the science endeavor, we had a lot of bullies that we nickname lecheros, right? And these are the, your people, since I love, statistics analysis and betting, the people that you will bet on them, right? They have that high GPA, the perfect GRE, very strong background in chemistry in my case, right? They are the brightest students that you will want your lab to be equipped with if you're a professor, right? And they're us, where you're barely surviving with a GPA of 3.0. I was, right? My verbal GRE was a disaster. I'm like, I have never heard of these words in my life. Where are they coming from? Is this even English, right? And the same thing happens with my TOEFL. So TOEFL is the test that you have to do as the English test for English being your second language, right? And I failed that exam 3 times, right? And the fourth time, the Fulbright office was like, if you don't pass this, we are just revoking your scholarship, right? So I barely passed that TOEFL exam, right? So I barely survived. There's a lot of people that, think that we have a lot of potential energy just to say that we have some energy, but normally what potential energy is just energy that you're not using. So normally you want that energy, that potential energy to turn into, let's say, kinetic energy, so movement, right? So again, if you were betting, which one would you bet on, right? I'm pretty sure that a lot of people will take this box, right? Because you will think that these are the ones that are most likely to succeed. But if I go back to betting, right? If I had to place a bet here and I put, I don't know, $1, I put $1 here, probably your winner would be about 15 cents. Okay. If I put $1 here, since nobody is thinking that you're going to be successful with these kind of categories, if I put $1 there, probably this will give me about $100,000. Okay. So the gain that you have by betting on underdogs is actually higher than people that you believe are the most likely to succeed. Okay, so this has been clearly reported in Science, where there's Nature is a very prestigious journal in science that published this and said no place for bullies in science because this actually happened, right? Okay, so the good thing about being underestimated is that that is one of the biggest competitive advantages that you have, right? And the same people that were being investigated, which are my cohort that started with me in graduate school, they are very prestigious scientists, right? All with a GPA of barely 3. We barely spoke English. And we are at very high levels in our careers, right? If I actually go back to the lecheros, I don't even know where they are right now. So they are not doing very well, okay? Okay, so as Cardi B will say, because I'm a fan of Cardi B, go ahead, underestimate me. You won't be the first, you won't be the last, but you'll be wrong. So take this as an inspiration to prove people wrong, right? The only person that should make decisions about yourself is you. The only person that should put you in a box is you, right? So don't let anybody define you or tell you that you are not doing well. Okay, so going back to what I was talking about, lack of role models, right? If I think about the music industry, right? And perhaps if I had a live audience right now and I asked everybody who these people are, probably everybody know them, right? And, yeah. But if I actually go to this portion right here, right, and I focus on these 3 scientists that I'm sure, regardless of you being a scientist or not, you know who they are, right? Because you perhaps are not familiar with their work, but you have heard of them, right? So we have Marie Curie here, Albert Einstein, and then we have Isaac Newton. A lot of people don't know this guy, but this is Garrett Morgan, and he's the one that invented traffic lights, right? And the thing is that the perception that we have about science is mostly dictated by a certain group of people, right? Like, okay, so this is how my professor should look like. This is how a scientist should behave like, right? And again, is putting people into a box that fit that particular person, not all of us, right? And then if I actually go back to, talking about Hispanics, right? Normally we are not associated with science, right? And even with Panama, whenever I tell somebody that I'm from Panama, the first thing that they ask me is like, oh, do you know Noriega? I'm like, yeah, I'm sure. I know that he was a dictator. I was very small at that time, but I am not associated with the guy. So why do you put the whole country under the lens of being a drug dealer or something related to that? It's not, right? The same thing happens with Mexico or with Colombia in the case of Vasquez Gaviria, okay? All right, So what does the lack of role models do for us, right? They mislabel us, they underestimate us, they give us the sense that we are incapable, and we never get the respect that we deserve. And sometimes it could be deflagrating, right? And there's a couple of examples here that I'm gonna make more on a general perspective, but if I actually talk about this guy, probably you will not know who this guy is until I say what I'm going to say, but he's actually the producer of Black Panther. Okay, and he was taken to jail because they thought that he was going to rob a bank, because he went to the bank to ask for a very high amount of money, which was from his bank account. But they called the police thinking that he was trying to rob the bank. Okay. Another one here, more on the personal note. So this is my son. And at that time, he was what? I think he was like 3 or 4. Now he's 7. So this was a few years ago. He goes to swim classes. So I take him to the swim pool and I sit there on my computer, and then he comes to me and tells me that a guy gave him $100, right? And he's just like learning about numbers, and he knows the difference between $1 and 100, right? So he's like very excited that he got $100. And then the guy comes behind him and tell him like, oh, give that money to your mom. And I hope that you guys are able to put food in the table, given that I'm giving you guys this money. Okay. And I am like, I'm not going to get into a confrontational conversation with this guy or anything like that. I just said, thank you. I'm like, you are so tactful. Thank you. Right. But because, I mean, perhaps in his mind, he thought that he was on the best thing since sliced bread. I don't know. And I was like this close of just telling him like, well, if you feel so passionate about paying our bills, how about if you give me your Venmo account and then you can pay his college tuition? How about that? All right. So there are the misconceptions, because he sees us and then he just thinks that, you know, these are just Black people that probably they are struggling economically. Let me give them a hand, right? So there are all these misconceptions, and it was very interesting that the lifeguard saw what was going on. He's like, why he didn't give me the money? I'm like, well, I guess you're on the wrong side of the spectrum. I don't know. So I took the $100 from my son that was kind of pissed about it, and I gave it to the lifeguard, right? And then I'm like, take it, because I can guarantee you that you need it more than me. Okay. All right. So we have these role models, right? But then we go back to scientists that have done a very significant contribution to advancing our lifestyle, right? But I mean, this was like science of like 200 years ago, right? But we have people that are doing very groundbreaking work that is more up to date, right? I mean, I'm just going to highlight 2 examples here that I really like the most. So we have Juan Gilbert, that he's the one that actually, since we are in and I'm pointing out these examples because Juan Gilbert is the one that invented all the voting machines that we have in the US, right? And then a little bit less relevant, but still important, is Dr. Whittaker-Brooks. So she's a professor at Harvard now, but she is the one that was very instrumental to the development of the COVID vaccine, okay? And we don't talk about these people because we are so attached to Albert Einstein and Marie Curie and Isaac Newton that we just don't think about these people anymore, right? Okay, so we need more of this. So we can contribute by, you know, advertising people that are doing significant contributions to the world, right? And we have those, right? Okay, so and you can do your part by being positively contagious about spreading the word and recognizing that you are awesome, right? You might think that, oh, I don't have a PhD yet, or I have not done anything at this level, but just impacting your community and impacting the people around you is good enough, right? So that's what we need in the world. Okay, so let me go now in something that I call imposter syndrome. 1.0 because I had a bunch of these, but I'm just gonna go with the first one. It was when I was actually in graduate school, right? And then, well, people ask you like, "How are you doing?" And normally you will say, "Oh, I'm doing fine." I have, seldom do you get somebody who say like, "Oh my God, I'm doing terrible." Nobody say that, right? But there's a lot of different things that we don't know that are happening, right? Because we cannot read minds. But there's a lot of different things that could be impacting somebody's success. And if we actually remove those, um, people can actually be very successful, right? And in terms of research, when I was a graduate student, I came up with a technology that actually funded this company. So it's called Demian. So it's clean manufacturing, where we actually ended up with a method to um, coat iron so we could have like an anti-corrosive surface, right? Mostly underwater. So why is this important? So we were commercializing this technology for the Navy, right? And why is that important? Because I mean, if you have a boat underwater and then you have all that salt, that corrodes metals, right? So by putting this coating, then you don't have to remove that boat out of the water or that ship out of the water, that warship out of the water, right? Then I started applying for awards, and there's where that imposter syndrome came back, and I'm like, why me? I'm not worth of it. I'm not, right? And I remember getting my first award, which was a material research award as a graduate student, very prestigious award in my area. And most of the time, these awards go to people at Ivy Leagues, Harvard, MIT, Stanford, things like that, right? And I remember being in the same room with all these very mind-blowing scientists. And I'm like, there's no way that I could compete with these people, right? And I got the award. But that again was my imposter syndrome talking to me that I do not belong in this group. I'm not good enough to be in this group, right? Without realizing that I am good enough to be in this group, right? So the same thing happens with the L'Oreal fellowship that I got actually from the L'Oreal Foundation. It's actually really good because they send me makeups and a lot of perfumes every year, which I love, right? And then as a faculty, having this talented 12, as I said, it's 12 scientists across the United States that only have it. But when I was applying to all of these things, there was always the doubt in me that I was not good enough for these things, right? And then I started my job here, and for me, this was the most rewarding thing because then I got to meet a very stellar group of students that I got that basically had imposter syndrome, and they reminded me of me so much that I'm like, all right, I'm going to hold their hands and we are going to go through this, and they're going to be the best students that I can mentor, right? Okay, so what I call imposter syndrome 2.0 is when I'm coming to Utah. So I was here in Buffalo where I did these coding materials, and I went to Princeton as a postdoc where I was doing flexible electronics. Then I started at the University of Utah, right? And then here I'm like, okay, so what am I gonna do with my life? I don't know. And this was actually very hard, right? Because then I have a bunch of colleagues that I always admired, right? And it was very interesting that they will ask me like, what do you do for fun? How was your weekend? Like very routinary questions that you will get, right? And or like they will tell me like, oh, okay, so what kind of experiments, like where's your lab going, and I'm like, gosh, I have no idea what I'm doing. Right. Or when they gave me my lab and it was empty, I'm like, what is the first thing that I'm gonna buy? Like, who is gonna be my first student? Like, why does a student want to work for me? There were so many questions that I had at that beginning that were just like increasing my anxiety levels, right? And then I started thinking, okay, fine. what I just like try to fit in their box now, right? So now my colleagues are asking me like, what do you do? Oh, how was your weekend? I'm like, sure, I was working. I was working the entire weekend, right? So I started giving them the answers that they wanted, that I thought that they wanted to hear, right? And and that's not true. Like that is not what I was doing. Like I was just out having fun. I watch a lot of soap operas. I like marching bands, so I actually go to a lot of events in New York to look at marching bands and do silly things with my kids. And I'm a family, right? But sometimes that does not translate into what people think that you are doing professionally, right? So let me just talk before I close a lot of these things about my research, right? So I'm a material chemist, but I also have a background in chemical engineering. So we actually combine a lot of materials fabrication with device fabrication, right? And that ranges from fabricating batteries, sensors, bio devices, thermoelectric devices, flexible electronics, and quantum technologies, right? Okay, so why do we care? So it was this paper that was published, I think it was last year, and featuring a material that is called LK99. So the L and the K comes from the author's name. So the Kim and the, where's the Ali here, all right? And then 99 because they discovered in 1999 and they just like keep beating this material up to find some properties, right? And what they claim is that we had like the first room temperature superconductor, right? And we do not have a room temperature superconductor today. So a superconductor is a material that can conduct electricity with no resistance, right? And that will completely change the semiconductor industry, right? So we could have like very fast trains, very fast cars, very fast computers, and things like that, right? So I always joke with my students, well, and joke and very seriously, like if you actually find a material like that in my lab, that would be even bigger than hitting the mega ball or the powerball or whatever they call mega millions or powerballs, right? The lottery, right? So you will be as rich as Elon Musk. So that's how impactful it would be to actually get this material, right? Okay, so they publish a lot of different things here, showing that yeah, there's no resistance here because I see that there's drop to zero, right? And then another feature of superconductors materials is that they can levitate. So you have that levitation here because of the magnetic field. So perhaps you guys are too old to know this show that is called The Jetsons. But if you actually go back to and you get the opportunity to watch this show, you will notice that a lot of the technology that they were forecasting in this cartoon are actually real today, right? So everybody was like, oh, we're gonna have flying cars, flying everything because you can levitate, right? And this was very suspicious. And why was it suspicious? Is because these scientists did not pay attention to details. And the details in this case was actually impurities, defects, right? So if they actually quantify the defects, then you will see that the resistance change that they were seeing here was actually associated with a structural phase transition. So not really a change in resistivity coming from a superconductor, right? So if you actually remove that defect state, right? So if you actually remove that, then you just get the most boring crystals ever. Yet they're very pretty. So they actually make like a really nice ring, right? But that's about it, right? Okay, so what my group does is that we actually look at synthesis of materials by combining organic and inorganic materials to come up with new materials, right? And perhaps one of these days we will hit the jackpot and get a superconductor material, but we draw a lot of different crystals. Here, we play with different strain interactions in materials to generate light, like in this case, right? And most importantly, we can then assemble these into functional devices. So I'm just gonna talk about two devices here. So these thermoelectric. So a thermoelectric is a material that converts heat into electricity. And then I'm just gonna cover a few things about battery materials in general, right? So let's start with thermoelectrics. So with thermoelectrics, you want to increase this thing that is called figure of merit, right? And the way that this is done, just looking at the mathematical number that is here, is that you want to increase this S. So this is called Seebeck, right? Then you want to increase this other parameter over here that is called electrical conductivity, okay? And then you want to decrease, because that is in the denominator, so you want to decrease this part that is called thermal conductivity, okay? The issue with that is that if I actually had to go to, let's say, to a playground, if you've ever been in a playground, right? There's a reason why you have a slide on a playground that is plastic, right? Because if the sun is shining and you have it made of metal, what it's going to be doing is that it's going to conduct a lot of heat, right? And you don't want that, right? So plastics are very good at dissipating heat, but they do not conduct electrical conductivity. So they do not conduct electrons, right? So basically what you're trying to do is reduce this number here. So that is what we call the carrier concentration. So I'm trying to reduce the amount of heat that my material is conducting, yet maximizing the amount of electrical conductivity, the electrons that are passing from one side to the other, okay? This is very hard because if you increase the conductivity, the electrical conductivity, you also increase the heat of the material, right? So you're basically trying to find a material that is neither or, right? So it's not a metal, it's not an insulator, right? So it's kind of like having a sweet spot where you have like Democrats and Republicans fighting, but you actually want like a bipartisan bill, if that actually makes sense. So that's what this graph is trying to say. So I know that with an insulator, this is going to go down. With a metal, this is going to go up, but I don't need any of those extremes. So what I want is a sweet spot here in the middle. So I want a material that behaves both as an insulator and both as a metal, right? So this is hard, but we know that it's possible because if you actually think about the effects of generating power from heat, right? It's also is at the very high end of what, let's say, nuclear energy would give us, or solar energy, or hydro will give us, right? If you actually think about the human body is something around here, right? It's not very efficient if you're thinking of like running a car with your body power, but it can perhaps power your phone, right? And we're gonna go that into more detail in a minute. Okay, so what my group is doing is like, well, we need to come up with a material that behaves both as a metal and as an insulator. So it's kind of like a love and hate relationship, right? So I have to find these two mixes. So what we do is that we play a lot with these inorganic nanowires, and then we mix it with organic structures. So the inorganic material is very good at conducting electrons, and organic materials are very good at conducting heat, right? So if we mix those two together, right, they would just take the best of both worlds, right? And then we make these films, right? And then we can actually make inks and put them into functional devices like the one that we have here. And then we can just generate a thermoelectric device, right? And what I'm doing here is just showing you fingertips of one of my students, right? And there you will see that by just pressing on that device, then you have a change in that, or you are generating an electricity output. Okay, so the same thing we can do by attaching that to their body, right? Don't look at their abs because they go to the gym quite a bit, right? And then if you actually do that and then they just go jogging or whatever, then you'll see that there's a little LED there that is possible to light up and generate electricity from the heat that their body is producing, okay? And just to give you a visual example of that, so this is one of our thermoelectric devices. We can cut it and make it bigger, make it smaller, whatever we want, right? And, or we can cut it or whatnot, but then if he actually, presses on that device, and we see that there's a voltage generation response here, right? And then if he touches the outer side of the electrode, because it's two electrodes, it's positive and negative. So if he touches the positive, the voltage go up, touches the negative, then you will see that the voltage will go down as we're seeing here, okay? So since this is a very broad talk, we do not focus on the axis here, but the axis is very telling in that the amount of voltage that his fingertips are generating is very small. So basically, if he's in trouble and needs to call 911, he probably has to run from here to Virginia back and forth to get like a 1% battery charge in order to call the police, right? So right now it's not very efficient, but is the first step towards us generating more efficient devices, right? Okay, so let's go into the talking about batteries now, right? And the thing with batteries is that we are always in an environment where we want to power our electronics faster, right? We want more energy, right? The fact that we want to power our electronics faster, and we also only want to power it once a day, right? So we actually want a lot of energy out of that fast charging, right? And there's a lot of different materials that we can think about in terms of batteries, right? So here's me with Stan Whittingham. So he got the Nobel Prize in Chemistry a few years ago for his development of battery materials. And a lot of the materials that he has developed are currently in most of your battery, most of the electronics that you use, okay? Okay, so what is the problem here, right? So even though that this effort started in 1972 and he got the Nobel Prize in 2021, right? In an electrochemical system, you typically have an anode, a cathode, and then you have an electrolyte in here that helps with masses that are moving back and forth, right? So you always have a mass that's moving back and forth. And that actually is very dangerous. And that's why you will see a lot of lithium fires, because then that generates heat, right? And then with that heat overload, then there comes that explosion, okay? So from the cathode side, right? So from the cathode side, we have a ton of materials. From the anode side, we don't have that many. So we have been using the same material that was developed in 1972, lithium, right? Okay. So then we have done a lot of work on trying to generate materials beyond lithium, okay? And I'm just going to speed up here, but beyond lithium, and what is the problem with lithium, right? So one of the problem with lithium here is the production and the reserves of lithium across the world, right? As Americans, we always want to be on the top, right? And if we actually look at this data, right, in metric tons and the amount of lithium that we have, even though that this number sounds like very high for the population that we have in the world, there is not enough lithium for everybody to have a computer and have a phone. There is not, right? However, if we think that we have enough lithium, right, most of the reserves are in countries that we are not friends of, right? Politically and perhaps financially too. So there's more production and reserves of lithium in China, right? There's a lot of production here in Chile, right? There's a lot in Australia, which is one of our allies, right? So I think Zimbabwe has a little bit too here, right? So the thing is that we actually, we need to figure out ways of moving from lithium or finding reserves, more reserves, right? And just related to Utah, recently we found a lithium reserve close to the Great Salt Lake. That makes a lot of sense because, I mean, if you think about the amount of minerals that are, and we actually know that we have that lithium reserve mostly because of climate change, because the lakes are drying up, so you expose these metals, right? So there's a big lithium reserve in the Great Salt Lake. But and then there's other critical minerals, so the semiconductor industry like cobalt and vanadium and uranium. But the issue here is that whenever you think about, there's a big difference between reserves and production, right? So if you actually want to mine that lithium, it uses a lot of water, right? And that is something that Utah does not have. We don't have a lot of water, right? So do we, I don't know, favor lithium production over water for humanity? Yeah, that could be a very battling question, but yeah. Okay, so the other issue with lithium is safety, right? So then we see a lot of planes catching fire, cars catching fire, whole houses being burned down because of lithium. So what my group is doing is actually looking at materials that we can use beyond lithium, right? And one of this is this titanium sulfide, but we have to understand what is going on at the atomic level. So we do a lot of microscopy to understand how lithium or how different ions are moving in and out of our materials, right? Lithium for microscopy is too small, right? So we actually have to go to sodium, which is convenient because we want to move away from lithium. So sodium actually works very good for us, right? So we do a lot of microscopy here at the nanoscale level, and then look at how lithium is moving in and out of our material. So here you will see this video where we have these droplets, and these are just lithium that are aggregating in our nanowires, right? As we apply a current, okay? So now if we reverse the bias of this current, right? So you will see that there will be sodium redissolution, because now it's going inside the wire, right? And it's being transported from one end of the wire, right, into the other end of the wire, because, I mean, it's being attracted by that change in the electric field. So then now you'll see that there's that lithium deposition right there. So we can do this experiment back and forth and then see where, not lithium, and we can see where that sodium gets trapped, right? Then we can actually map and then determine pathways for sodium, and then translate those pathways into lithium, and then figure out how we can generate better battery that do not catch fire, okay? So yeah, so I just want to summarize my research here, and just as a take-home message is that we are working with different dimensionalities here, where we address things that happen at the nanoscale all the way to bulk and device fabrication, right? But that is my impact as a scientist. For me, my biggest impact is thinking about, you know, how do I impact people, right? Because as I mentioned, if I go back to Albert Einstein, I mean, 200 years ago, his research, even though that is very seminal to the scientific community, has evolved a lot, right? So there's no papers that talk about Albert Einstein. There's no paper that talk about the work that he has done, right? But if we actually think about the impact that he has generated in us as scientists, is bigger than him coming with E=mc², right? And that is the same thing that I'm trying to do here, right? So what I will encourage you to think about is treat your goals as a thermodynamic function. And what do I mean by that? A thermodynamic function is function in chemistry that it doesn't matter how you start or how you end. It does, well, the metals, doesn't matter how you get there, doesn't matter, right? So you can think, well, if this is my goal, I can take this route, I can take the yellow line, I can take the green line, I can take the purple line, right? It doesn't matter how you get there, as long as you get there, right? So, and that is the biggest the biggest advice that I can have for you. Okay, so think about your cohort. This is my cohort. This is my PhD advisor that I love to death because I mean he is the one that actually shaped me into a scientist. This is my PhD advisor, and there have been these scientists right here that have, you know, they have provided a lot of support of me as a faculty here in chemistry. I have my husband, my son here, and then I have my my family here back in Panama, right? So, and my research group, right? So I always go back to my research group and the impact that I want to generate on the people that I mentor and I train, right? And I go back to this letter and I sit here and I will have never in my life imagined that I will have been doing this type of research growing up in a house that I took this picture a few years ago, the house where I grew up in Panama, right? If I think about that, there was no possibility of me being the scientist that I am today. Okay, so reach your goals. Think about the fact that there's this iceberg illusion. A lot of us, you will think of us as like very successful people that had no limitations in life, but that's just the tip of the iceberg. There's a lot of different things that happen underneath that that make us stronger. So don't take a failure as a overall failure, but an opportunity to learn about it and be better, right? Again, don't let anybody define you. You are the limiting factor, right? And think about this as a seed, right? So whenever, whatever you do, you are planting a seed and you're engaging into somebody to be better, right? So think about that all the time, right? So we are building roots, and the roots in a tree are actually the strongest part of the tree, right? If you actually think about seasons, in the fall, the leaves fall, but the roots are still there. And then in the spring, they will come back up again and they will look all beautiful because the roots are strong. So cultivate that strong root, right? And get back the gift of giving, right? Like I remember reading this, not from my perspective, but came across this on Twitter from a former student that was in one of my classes. And they posted this on Twitter because they were applying for graduate school at Harvard and they ended up being at Harvard. And when I read that, I cried because I'm like, this is the kind of impact that I want to generate on people, right? And with that, I have to finish with, thanking my group and thanking the people that trust and that trust in me and my mentoring style. That I'm not saying that is perfect, but is my mentoring style. And with that, I would like to say thank you. And if you have any questions, I'm happy to answer them.
I don't know if you can answer this quickly, but there was one question from a registrant. What drew you to STEM, and do you still have the same passion for the field now?
Yeah, so that has changed. And I actually read those questions. That had changed in that, when you start as a professor, I think it's mostly like, all right, let me think about my research agenda, right? But then it changes more to a teaching and mentoring agenda, right? And and then realizing that like I said, the research evolved, right? And perhaps the things that I'm doing right now will not be significant 10 or 20 years from now, right? But the people that I mentor and the people that are important to me will have a long-lasting impact than the research findings that I get in my lab.
Well, thank you so much, Luisa. This was amazing. If nobody else has questions, I just want to remind everyone about the event evaluation. I just put the link in the chat. The Europe, Wilkes, and early exploration scholars must complete that to get credit for today. And just to remind you, the Office of Undergraduate Research, we're in the SIL Center, which is east of the Union, or at our.utah.edu, and you can email us at our@utah.edu. And thank you again, Luisa. This was a very inspiring presentation.
Thank you.